In continuation, we have displacement. Displacement, as we have just talked about distance, we borrow from the definition of distance in defining displacement. And we say that displacement is distance covered or made in a particular direction or in a specified direction. For example, I stand here and face the north. I can move 5 meters due north from my reference point. Alright? Remember when I was talking about rectangular coordinates, the Cartesian plane, we used y for vertical or x for horizontal. This time around in displacement, we shall be looking at the compass, as you can see on the board. So, but in this my demonstration now, this is my reference point. For example, if I'm a vehicle or anybody in physics, I can cover 5 meters due north. Now, when I say 5 meters due north, that is my direction. In other words, my direction is defined. Do you understand? You can see on the board, 5 meters due north. Now, look at the compass. 5 meters due north. You can see I've drawn the compass here. Then this distance covered. Here, from here, this origin or reference point to this point, I can increase it. Let me increase the northern side. So maybe if I cover from here to here and say it's 5 meters, that is the magnitude of that displacement. But its direction is that it is due north. Somebody can draw it with an arrow pointing upward. Okay. Now, for 5 meters southeast, it will have another diagram. I can draw that one here. You can have 5 meters southeast is north, south, east, west. So southeast is somewhere here. And then you draw this line. This is showing the displacement. It is also measured in meters. So this arrow, this line with arrowhead is our vector. And then you say that, and then we call it a displacement, sorry. Now, we see that 5 meters, the magnitude of the displacement is 5 meters. What is the direction? Southeast. Southeast, when we talk about the compass, the angle is not given. When the angle is not given, it is southeast, southwest, northwest will be here. Northeast will be here. Then southwest will be here. But then that depends on the person that is presenting it. So in this case, the magnitude is given as 5 meters, and then the angle is not given. So, but once the cardinal points are being mentioned, that will indicate the direction. Another way you can represent this displacement as a vector. What is a vector? A vector is a quantity that has both magnitude and direction. As we can see in the definition of displacement, it said distance moved in a particular direction. That distance covered is the magnitude, and the particular direction is now talking about direction. That makes it a vector. And then you can see what I wrote here. After this first example, second example, then we are now on the third example. 5 meters, 20 degrees east of south. There is a way you now present it in compass bearing. Now remember, you learn bearing in mathematics. We have compass bearing and 3-digit bearing. When you are reading from, the north in clockwise direction, 300 degrees, we talk about 3-digit bearing. And I'm not going in details into that because here we are looking at physics. So, but we apply that knowledge in handling this. Now, let's refer back or go back to what we are discussing. Remember I said that in true bearing or 3-digit bearing, you go from the north all around, you go back. But in compass, it's either in the southeastern side or northeastern side, or the quadrants, you got a northwest and southwest. But then look at how we represent when an angle comes in between to indicate that direction. Now we are going to have space is going to be my problem now. Okay, let me draw it here. So you have another north, another compass, east, west, south. So 5 meters 20 degrees east of south. You have to draw a line here and then indicate 20 degrees. You don't measure it. Indicate 20 degrees closer to the south. And then you call it whatever vector P or vector K or whatever it is that is moving has covered 5 meters on the length that shows the magnitude, but then the direction is 20 degrees. Where is it? You don't say southeast in this case. You say east of north is, compass bearing mode. That is east of north, backward. East of south, backward. If it is here, it's east of south. East of north here, east of south here. If I come here and put 20 degrees here, you will now say 20 degrees east of north. But now that I am representing what is on number 3, 5 meters 20 degrees east of south should be on this quadrant. Remember there are 4. 1, 2, 3, 4. So like this one is having 10 meters 20 degrees west of north. It's going to be shown here. 10 meters, you increase the length, showing that it's of higher magnitude from the origin here, from the 0 point. And then where are you indicating the 20 degrees is here, closer to the north. That is, you now have 10 meters 20 degrees west of north. 20 degrees west of north. 10 meters 20 degrees west of north. That is how we write it. Okay? I need to clean this so that I'll write it again. Or you can even write it here as it is written here. That's how you show it. 10 meters 20 degrees west of north is this way, closer to the north, because north and south are the two major cardinal points. These ones are sub. Okay? In compass bearing, we maintain 2 digits, but then the east will be here in the front, and then this south will be at the back. In that order, like west and north, and in that order. Here, if it is here, you have east and north. Now, when the angle is not given, you come back to this one. 5 meters southeast. 5 meters northeast will be here. You draw a line that indicates the magnitude. The higher the magnitude, the longer the line, because it's a vector and it has to go with an arrow head. So at this level, or even at A level, it goes with an arrowhead. But there are many other ways we can discuss that. But when we come to the topic vectors, we go in details. At this point in time, we are looking at displacement. And I said that displacement is defined as the what? As distance moved or made in a particular direction, or in a specified direction, in a particular direction. So that distance you are covering is now the magnitude of that displacement. But the direction is the angle or the compass notation that indicates the direction of that motion. Once the direction is defined, you are now going to say that that distance is what? Called displacement. And then you have seen the examples, number 1, number 2, number 3, and number 4. So let's look at the similarities. Similarities is not written on the board now because of space. I've written the differences, but let me tell you the similarities. The similarities between distance and displacement. One is that distance has magnitude and displacement has a magnitude. So both of them have a magnitude. Number 2, they are measured in meters. Distance is measured in meters. Displacement is also measured in meters. The third one, you can say that borrowing from number one, that distance is a scalar. Okay? Yes, distance is a scalar. But then, let's have only two similarities, both having magnitude. That is talking about scalar. But then, that will take us to the differences now, so that no one will make a mistake. So, in their differences, I said, or we are saying that distance is a scalar, while this one is a vector. A vector. That is the major difference. Because I've told you that in their similarities, both are measured in meters and both have magnitude. Okay? Then the only difference we are bringing out now is that distance is a scalar and displacement is a vector. So what is a scalar and what is a vector? In physics, a scalar quantity is a quantity that has only magnitude but no direction. Okay? So in displacement, we now have that is a vector. A vector is a quantity that has both magnitude and direction. It's not only the displacement that is a vector. We have acceleration, we have velocity. Okay? They are all vectors. We have force, the major example of vectors. Forces, they are vectors, all kinds of force. All right? So we can say that velocity, vector, acceleration, momentum, they are all vectors because they have magnitude and direction. So in a nutshell, when we come to that topic, we'll talk about it. All right? So in summary, distance is defined as a quantity or a measure of length between 2 points. All right? The displacement is a distance measured in a particular direction. So distance is a scalar. Displacement is what? A vector. A scalar has only magnitude, and a vector has both magnitude and direction. And you can see from the examples I gave initially in distance that you just cover like 5 meter, 2 meter, 3 meter, 100 meters without a direction. And then you can see that in displacement there must be a direction. The compass must be defined in 3 or 4 different modes. First mode, you can see this 5 meter due north. You can be 5 meter due south. It can be 5 meter due east or due west, as the case may be. And then you have 5 meter southeast. In this case, no angle is mentioned. These are forms it can take. I have shown you here. It can be any of the size of the quadrant. And then here you have 5 meter, 20 degrees east of south, which you represented here. And then I said you can have 20 degrees here east of north. Now the last one is 10 meter, 20 degrees west of north, which I represented using the same compass. So thank you very much. We have seen the similarities and the differences between displacement and the distance. Thank you very much. Have a nice day.